Okay, here we are with lesson 5, finding 100% given another percent. So the opening exercise, go ahead and complete the table. For the factors of 100, which have several numbers, you can just mention the first 5 and the last 5 and use an ellipsis, which is the period, 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 to indicate the numbers in between. Check your answers when you are finished. Okay, you should be done with the opening exercise. And this is what you should have in your table. So as we start with 100, there are two factors, 50 and 100. The next one should be 25. So the multiples of the factors would be 25, 50, 75, and 100. It's like skip counting. So that means there's 4, and so on and so forth until you get to the last one, which again, you don't have to list all the numbers, but there would be 100 multiples of 1 to get from 1 to 100. So how do you think we can use these whole number factors in calculating percents on a double number line? Well, the factors represent all the ways which we could break 100% into equal-sized whole number intervals. The multiples listed would be the percents representing each cumulative interval. The number of multiples would be the number of intervals. So let's take a look at example 1. The use of visual models is a very powerful strategy for organizing and solving percent problems. In this example and the others that follow, the double number line is modified so that it is made up of a percent number line and a bar model. This model provides a visual representation of how quantities compare and what percent they correspond with. We use the greatest common factor of the given percent and 100 to determine the number of equal-sized intervals to use. So the problem, 42 students who play wind instruments represent 75% of the students who are on the band. How many students are in the band? So which quantity in this problem represents the whole number? Well, that would be the total number of students in the band, which is the whole, or 100%. So let's draw a visual model shown with the percent number line and a tape diagram. So this is the model you should use for the rest of these problems. Making sure that you have a line that equals 0 to 100%, and then a tape model that will represent the quantity and the whole of whatever it is we're talking about. Notice how 0 to 75% is modeled, the same as 42 students is modeled, because 42 students is 75%. So how do we find out the whole of this tape diagram? We're going to use a double number line to find the total number of students in the band. So 100% represents the total number of students in the band, and 75% is 3/4 of 100. The greatest common factor of 75 and 100 is 25. So basically you would divide the tape diagram into 4 equal-sized sections, each representing 25%. There are 3 intervals of 25% and 75%. Each of these intervals would represent 14 band students. You know this by dividing 42 by 3. The last interval also represents 25%, or 14 students, making 4 groups of 14 band students each, so 14 times 4 is 56. So there are 56 students in the band. All right, go ahead and use a modified double bar line to try exercise 1 through 3. Go ahead and check your answers after each exercise. All right, so you should be done with exercise 1. Let's see how you did. So this is what you should have as far as a modified line diagram, and this is the answer. So the salesman total is being compared to the total number of tires sold by the store. So the total number of tires sold is the whole quantity. The greatest common factor of 60 and 100 is 20. So divide the percent line into 5 equal-sized intervals of 20. So this is what they do here. If 60 is representing 165, then you would have 20, 40, 60, 80, and 100. So 60 is 3 of the 20% intervals, so you're going to end up dividing the salesman's tires by 3 also, because here is 1, 2, 3. So we're going to divide 165 into 1, 2, 3. And so when you do that, dividing 165 by 3, you will get 55 tires to correspond with each 20% interval. 100% consists of 5 20% intervals, which corresponds to 5 groups of 55 tires. So 5 times 55 equals 275. So the record number of tires sold was 275. So if you did 55, 55, 55, 55, and 55, that's where you get 275. All right, here is number 2. Nick currently has 7,200 points, which is 20% more than Adam. So how many points does Adam have? Well, if Nick has currently 7,200 points, and that's 20% more, then that's going to be 120%. Adam is 100% of that, and we don't know what that is. So what ends up happening is, since Nick's points are being compared to Adam's points are the whole quantity. Nick has 20% more, so Nick really has 120% of Adam's points. The greatest common factor of 120 and 100 is 20. So divide 120% into 6 equal-sized intervals. That's what we did here, 20, 40, 60, 80, 100, and 120. And then divide Nick's 7,200 points into 6 intervals. So 7,200 divided by 6 is 1,200 points. So if you only do 6 of those, 1,200, 1,200, 1,200, 1,200, and 1,200, you're going to get 6,000 points. So Adam has 6,000 points in his fantasy football league compared to Nick's 7,200 points. All right, and here is number 3. Kurt has driven 276 miles on his road trip, but has 70% left to go. So that means that he's completed 30% of his trip, so that equals 276. Well, what is the common factor between 70% and 100%? Well, that would be intervals of 10. So splitting it up into intervals of 10, how many intervals are in 276? Well, that would be 1, 2, 3. So you're going to divide 276 by 3. That should give you an answer of 92 miles. And then you're going to take 92 miles and multiply it by 10. So that would give you 920 miles. Now this is a little different because they want to know how much he has left to go. If it's a total of 920 miles and he's already done 276, then you have to subtract those two numbers and you end up with 644. So the remaining miles that he needs to go is 644. And that's what makes this double line or double modified line bar graph helpful, because it allows you to visually see how to answer the question. All right, let's take a look at example 2. We're going to practice using mental math and factors of 100 to determine the whole quantity when given a quantity that is a percent of that whole. And we're going to explain the method. So here's the first one. If 39 is 1% of a number, what is that number, and how did you find your answer? So again, keep in mind thinking about factors of or multiples of 100. If we're comparing 39 to 1%, 1% is what of 100%? Well, there would be 100 of those. So 39 is 1% of 3,900. Because if I take 39 and multiply it by 100, because again, there's 1% and there's 100% or 101% and 100%. So 39 times 100 is 3,900. Let's look at the next one. If 39 is 10% of a number, what is that number? And how did you find your answer? Again, think of the factors. How many factors of 10 go into 100? Well, you should have answered 10. So if 39 equals one of those 10s, then, and there's 10 of them, then basically you would multiply by 10. So 39 times 10 is 390. What if 39 is 5% of a number? What is that number, and how did you find your answer? So now you might want to, there's a couple different ways to do this, but if you think of what are the common factors of 5% and 100%, you would know that that would be 20. So you could do 20 times 39. Another way you can think of this is what is half of 390? Or actually, what is double that? Because if we're taking half of that, then what ends up happening is we are multiplying it by 2. 390 plus 390 is 780. So again, 5 is a factor of 100. Since there's 20 of them, then 20 times 39 is 780. So here it is broken down. You can think of it by splitting it up into easier factors. So factor 20 into 39 times 2 times 10. Then all you really need to figure out is 39 times 2. Well, you can use some rounding. 39 is close to 40. So 40 times 2 is 80. And since there's a difference of 2, then that means that we would have to take away. So that would be, instead of 800, it would be 780. So when we get 78, that would be 78 times 10 is 780. Let's try this one. If 39 is 15% of a number, what is that number? And how did you find your answer? Well, 39 is 15% of 260. But 15 is not a factor of 100. However, 15 and 100 have a common factor of 5. So going back to our 5%, if 15% is 39, then that is because 5 is equal to 15 over 3. So 15 or 5% is equal to 13, which is 39 over 3. There are 25% intervals in 100, so there's 20 intervals of 13 in the whole. So here's another way of thinking of it. 13 times 20. 13 times 2 times 10. So this is easy. 2 times 13 is 26. And 26 times 10 is 260. If 39 is 25% of a number, what is that number? This one should be a little bit easier because you're more familiar with 25%. Well, if 25% is 4 times 25, then that means that you would be doing 4 times 39, which is 156. So again, trying to break this up into an easier problem to do it mentally. Instead of 39 times 4, think of it as 39 times 2, because it's easier to do 39 and 39. What you end up with is 78, and then 78 times 2 is 256. All right, using those examples, go ahead and do exercises 4 and 5, and see if you can do them mentally, but being able to explain how you use the factors to help you do the mental math. All right, so you should be done with number 4. You would have come up with the decimal of 250 thousandths is 25%, which means that Derek had a hit 25% of the times that he batted. The number of hits being compared that he was up to bat, well, that's 47 hits corresponds with 25%, and 25% is a factor of 100. So 100 is equal to 25 times 4. So we're going to do 47 times 4, which is the same as 50 minus 3. So I know what 4 times 50 is. That's 200. And I can do 4 times 3, which is 12. And now it might take a little bit of work to do 200 minus 12, which is 188. All right, here's number 5. Nelson used 35% of his savings for his class trip in May. If he used 140% from his savings account while on his class trip, how much money was in his savings account before he was on the trip? So again, 35% is representing 140. So you have greatest common factor of 35 and 100 is 5. So 35% is 7 intervals of 5. You could divide 140 by 7 to find that $20 corresponds with 5%. So if 100% is 5% times 20, the whole would be $20 times 20, which is 400. So that means Nelson had an account of $400 in it before his class trip. All right, let's wrap this up. What does the modified double number line method and the factors of 100 method have in common? Well, both methods involve breaking 100% into equal-sized intervals using the greatest common factor of 100 and the percent corresponding to that part. Can you describe a situation where you would prefer using the modified double number line? Can you describe a situation where you would prefer using the factors of 100? And to find 100% of the whole, you can use a variety of methods, including factors of 100. 1, 2, 4, 5, 10, 20, 25, 50, and 100. And double number lines. Both methods will require breaking 100% into equal-sized intervals. Use the greatest common factor of 100 and the percent corresponding to the part. All right, we'll see you in class.